Hey, everybody, welcome to today's show. We are super happy to be joined by a world renowned theoretical physicist, cosmologist, New York Times bestselling author, Lawrence Kraus. We are going to pick his brain. It'll be a shorter interview today because he's a super busy guy, but we're very excited to have him join us and very humbled that he agreed to do this. So get that coffee going, get in the comfy chair, and welcome to Quantum Ladder Podcast. Welcome back to Quantum Ladder Podcast. My name is Louis Borges. Joining me, as always, my good friend and co-host, Marquise Williams. How are you, sir?
Fantastic. It's an exciting day. It's a really
exciting day. Yeah, we're joined by a proper genius today, and we want to ask him about all the big questions and all the things that, we sort of ponder on, and I'm sure our audience does as well. So without further ado, we will bring on our esteemed guest today, Mr. Lawrence Kraus. Welcome to the show.
Well, it's good to be with you. Thanks for having me on.
Yeah, thanks for taking some time out of your day. We know you're a super busy guy, so we'll be prompt and respectful of your time. So let's get right into it. Tell us a little bit about yourself and what got you into the field of study that you chose as your path.
Okay, good. So, sorry, did you ask a question there? I was just saying I'm sure you're super busy too.
Yeah, no, tell us a little bit about yourself and what got you into the field in life that you chose.
That's good for an hour. Let's see. I'm a theoretical physicist, which means I don't do experiments much as I would like to now, and that's important. A lot of people don't realize that physics, especially, is advanced enough that people tend to specialize in either doing theory, which is sort of thinking about how to explain experiments or how to explain anomalous results, or coming up with ideas for which experimenters can then test. And my area of research has been initially particle physics, elementary particle physics, the fundamental forces that hold everything together. But early on in my career, I decided that the universe was a good way to test those ideas. The universe is basically one massive particle physics experiment that got done once, and now it's data analysis, really. It allows us to probe regions of physics and scales of physics that we can't yet reproduce in particle accelerators like the Large Hadron Collider, the earliest moments of the universe. There were incredible energies that we can't reproduce today, and maybe in quasars and other areas and black holes we can probe physics that we can't probe in the laboratory. So anyway, that's my areas of research have been primarily the beginning of the universe and the end of the universe, and every now and then something in between. I got interested in science. It's hard to say; it's a long and winding road, but one of the things that got me interested was books by scientists when I was a kid, and that's one of the reasons why I write books now. Besides my science, I've written 12 books now, and lots of obviously public articles as well. But books by scientists, by Albert Einstein and Richard Feynman and George Gamow, got me interested in science, and I kind of returned the favor now. And anyway, that's a short introduction. How does that sound?
That's perfect. Thank you for that.
Fantastic. I saw you did an interview with Robert Sapolsky the other day, and
yeah.
I just want to say that the idea that you two together, two people that I've been looking into for, I don't know, like 10 years now, have shaped my perspective about the universe and humanity, civilization. That was fantastic. You guys were talking about the idea of determinism, I think it is, and free will. Can you give me some insights there on that conversation?
Well, it was a 3-hour long conversation. So
I know.
Robert's a great guy, and I'm glad. Yeah, it was fun for us to have finally the chance. For years, we've been thinking about doing something together, and it was nice to finally be able to do it. We come at it from different points of view. As a physicist, I guess I've long recognized that the universe is deterministic. The laws of physics, even quantum mechanics, is deterministic. It's the fundamental equations of quantum mechanics. There's what are called second order differential equations, Schrodinger's equation, for example. And so if you could define what's called the wave function at a certain time, it tells you how the wave function propagates. Now, what you measure may be probabilistic, but what the laws of physics, underlying laws of physics, are deterministic. And so I kind of recognized that free will was an illusion already, because of course biology is based on chemistry, which is kind of based on physics, and ultimately there's no kind of missing magic spot in the middle for something unexpected to occur, I guess. And Robert, of course, being a neurobiologist, has looked at this from the point of view of the way the brain really works, mm-hmm. which of course is important and an area that he has much more expertise than me. And he's really the same idea, that from the neuron to the brain, there's nowhere a gap, as he likes to call it, turtles all the way down. If you try and say, well, okay, where's the place where free will can enter? And, starting with the neuron, which is governed by, laws of biochemistry and physics, all the way up to the brain, there's nowhere where you can see where suddenly sort of free will sneaks in. And that's the short version of a very long conversation. But the other thing that's really quite important, and I think in the end, is the consequences of that. And he takes them quite strongly, that ultimately the notion of societal punishment, mm-hmm. I think he agrees with me. We need to take responsibility for our actions. They may have been determined by a whole set of things we can't control, but we did them. And but society can try and protect its members, but to punish people is a little bit different. So he would view incarceration as a kind of way to keep people who, for one reason or another, are dangerous out of society until they're not dangerous anymore. But not to punish them, not to produce an environment that's horrible where they have to live in rat-infested cells, but rather to live to treat them as human beings and to try and help them. But anyway, it was a fascinating conversation. We could have gone on for another 10 hours. He's an amazing man, and we both enjoy explaining science. And so anyway, yeah, it was really not only a lot of fun, but it's one of the few times I've chosen to do this. I knew his new book was coming out, and I had an advance copy, and we wanted to record it in time for the publication date of the new book, which, I've had people's books in advance, but I don't always time it that way. But I thought for Robert, I would time it that way. So we did it on the pub date.
And in addition to you being an amazing author, you host the Origins podcast. Some of your guests have been Neil deGrasse Tyson, Jordan Peterson, Roger Penrose, William Shatner. It's the A-list of science.
Yeah, no, no, I'm very lucky on the list of people we've had. It's been and I do the podcast. I should have said that as part of my intros, that it's part of the nonprofit foundation that we created called the Origins Project Foundation. When I left the university, I created the foundation to try and tie together science and culture and introduce people to the key ideas that are driving the 21st century and to the people who are doing it. A way to kind of excite people about the frontiers of science, but also to show that science and culture are not two separate things. And that's why we jump between scientists and writers and actors and directors and journalists and it's interesting people who are thought leaders in one way or another. And so it's been very humbling, to use the word that you used, for that a lot of these people have agreed to be on the program and trusted me to spend 2 or 3 hours with them.
Sure. And my question is, how do you communicate sort of complicated physics to a general audience? I mean, we're not PhD scientists. We're just scientific enthusiasts. We have geniuses like yourself to help us with the hard stuff. But how do you manage that? Not talking over people. So, you know what I mean? Over their level.
Yeah. Well, I think, look, I think the key thing that I always think of when I try to explain something is, how did I first understand it? What process did I take to first understand something? And then try and reproduce it for other people. That's a very useful tool I used to work for a science museum when I was a kid in Canada, in Toronto, called the
My
Ontario,
hometown.
Ontario Science Center, and I worked there when it first opened. And it was a kind of a vaudevillian kind of introduction for me to science communication, because I used to do 10 shows a day of electricity and other things. And I used to start to improvise, it was really useful to learn what arguments worked with people and what didn't.
Yeah.
But I guess I try and think of, like, I think any teacher has to, or anyone, any podcast host or a car salesman, not putting them in the same boat, but all have to think about, if you want to get people interested in what you're talking about, you have to go to where they are. You can't expect them to come to where you are.
Yeah.
And that means thinking about explaining things in terms that might interest them and grasp their enthusiasm. And then they'll start to come to you. And so I've often told teachers that the biggest mistake any teacher makes is to assume their students are interested in what they have to say.
Yeah.
Because you have to get them interested in what you have to say. So there's a combination of things. Plus, in the case of the kind of work I do, which has been pretty mathematical at times and esoteric, there are concepts that are indeed challenging and far removed from what people are used to. And so there one has to look for good analogies often, because one can't talk in terms of the mathematics. Mm-hmm. And that, again, is a matter of experience. And it's trial and failure. Some things work and some things don't. And often it's a good way for me to understand things a new way. When I've written books numerous times, ideas that I thought I understood fully, I realized I didn't understand until I tried to explain them, and then realized that I had to do a better job of explaining, and therefore of understanding myself.
It's bizarre to hear you say what you just said, because from my perspective, a guy who doesn't have that kind of intelligence and genius, I always feel like that. But to hear you say you feel the same way kind of makes me feel like we're kindred spirits, you know?
We are. It's nothing different. It's all the same kind of stumbling forward and trying to understand.
Yeah.
And create pictures for oneself. So I don't feel a big gap. I've been fortunate to be supported to, play around with the universe. And that's a great privilege. And that I try not to take lightly. To be able to be paid to do what you want to do and have fun is a real privilege. And I think probably too many academics don't, I think in my experience, don't really recognize it as such a privilege. It's not really a job.
How do you deal with skeptics or criticism when, you're a scientist and there's plenty of people who are not scientists that like to argue with scientists? So how do you deal with, even with things like climate change, deniers and stuff like that? How do you approach that?
Well, I think that's one of the reasons a lot of scientists are hesitant to enter the public arena. First of all, part of them are just many feel uncomfortable anyway. But because you expose yourself to a wide variety of sort of attacks that you wouldn't be subjected to otherwise. Academia is a pretty safe environment. Very safe environment, and when you move outside of it, it's a different world. One of the reasons why, but frankly, I've always enjoyed having a foot outside academia, because for some reason my personality is such that safe world never seemed kind of enough. I think the idea is that you get people coming back to you, and some of them are well intentioned and some of them aren't, and I think the idea is to I was going to say confront, but that's really not the right word. To interact with those people who are well intentioned, and to work with them to try and address issues of because sometimes they may be right. That's the other thing that's really important.
Yep.
You can change your mind, and it's a lot of people don't realize that, but changing your mind is really important. And the ones who aren't well-intentioned, there are different ways of approaching them. I think ignoring them is usually the best approach. But sometimes, if they have an audience, and it's really not them you're trying to communicate to, it's the audience. You sometimes have to confront them directly and try and think of arguments. You're not going to convince a true believer. You're not going to convince a religious fundamentalist, that the world isn't 6,000 years old.
Yeah.
But hopefully what you can do is the people who listen to that person and listen to you talking to that person, if you do it right, may change their minds. Mm-hmm. And so I think you have to think about who your audience is and what are you trying to accomplish. It's not it's too often, are you trying to win a debate? It's like a game, or you're trying to do something more important. And then when you realize what you want to do, I think it helps guide what you do. Not always. We're all subject.
Sure.
Reason is the slave of passion, and
Mhm.
and so we're subject to that.
Well, I watched your debates many years ago. I watched a lot of your debates, by the way. They were what brought me on to you years
Oh,
ago. But I
you're
got to
not.
ask
Well,
you.
it couldn't have been that many years ago. You're too young.
Well, yeah, I'm a little bit older than I look, but yeah, it wasn't too long ago. I think it was like maybe 8 years ago. It was when I
Uh-huh.
first saw some of your debates, and I was like, "Oh, this guy's he is masterful on the stage." But I wanted to ask you because you were talking about education and about how about reaching audiences and meeting people where they are. Artificial intelligence. Um, this is a two-part question. The first part is, what do you see artificial intelligence, or how do you see it affecting civilization? And two, are you going to interview Sam Altman or maybe Mustafa Soliman or something like that?
Well, the answer is I may do that. Yeah, I actually have a really interesting podcast coming up that we already recorded with, in my mind, one of the most brilliant theoretical computer scientists who's now working on AI safety. Scott Aronson is his name. He's
Mm.
and it's anyway. I think it's a really interesting conversation about AI and about computers and quantum computing, and then about AI and AI safety. But of course, I don't know what the future of AI is. Happily, I as I said in the new book, I don't know are the three most important words in science because it's an invitation to discover. And I also have said often that I don't like to predict the future except for 2 trillion years in the future, when it's much easier to predict what will
Yeah.
happen, and also no one will be around to test my predictions. But AI is going to change the way we live and work and what it means to be human. But that's not unique. That's true of all technology. Uh, um, all of our technologies have changed really what it means in daily life, not just cars and TV and radio. Smartphones have changed how we behave and interact as human beings. And AI is going to do that. It's just another part of our technology. Now, as many people have recognized, in principle, since we really don't know what the limits of AI are, or even what it is. I mean, I've often say it's neither artificial nor intelligent at this point, but it has the potential, we think, to recreate even consciousness, if we understood what consciousness was, and therefore, and also far surpass human capabilities, because you can process much more information right now in AI, at least in terms of data mining, than an individual human can do. We already see that in certain areas. So it has the potential um, to be an incredible aid for humanity in terms of allowing us to do many things better than we can do. But of course, it has also the potential, as some people recognize, because it may surpass our capabilities, of going out of control in some sense. And many people are worried about this, dystopic futures, the transformer futures, or robot futures that in which AI either takes over or destroys humanity. I'm not as worried about. I guess I'm not as worried about that. I think we have to think about that, and Scott Aronson and others do think about ways that we can try and ensure some controllability. But it's an interesting future. I'm fascinated. I'll be fascinated to learn new physics from quantum
Yeah,
computers,
yeah.
and the future of intelligence on Earth may not be biological. Okay, well, that's the way it is. Humans will have to adapt. And, maybe it doesn't mean the future has to be bad. The example I used at the end of my last book, The Edge of Knowledge, is that comes from the 9th century and 8th century BC in Greece, where the Phoenician alphabet was integrated into, where writing began to become dominant. And Plato and Socrates were desperately afraid of writing, in the sense that they said it would destroy storytelling. You lose memory if you could tell stories and instead of write them down. You have memories, and as I think Socrates quoted as saying that, you can't question a book, you can question a person. So they thought it was the end of knowledge and storytelling. Well, it didn't turn out to be the end of storytelling. It turned out to be a pretty good thing for storytelling on the whole. As someone who writes books, I may be biased, but I think books make it better. So, it takes us in different places, in different directions than we would know, but it didn't make the world worse. It just made it different. And as I also said in the climate change book, we do have some control over the future. The way I put it was that the future is racing towards us like a freight train, but it's doing so on tracks that we've built. And so we can try and think about the alternatives and act reasonably. But it's hard to control new technologies in a complex society and how they're used. So it's going to happen, and it's already happening, and it's improving some things and changing the way we do things. I think there are a lot of jobs where I think AI can probably do clearly a better job than humans, and they're not the jobs like of sort of manual labor jobs that some people thought robotics would get. They're not. I don't think home building is the key place, for example, where AI is going to have an impact. But in law and medicine, I mean, in diagnostics, for example, I fully expect AI be able to do better diagnostics than many doctors. Okay, well, that's just the way it is. It's it means doctors can do other things, or people who are trained as doctors can do other things, and ultimately, it could be AI frees us up to all spend more time in coffee shops listening to music and reading books. That would be a great future. Or it could be that the people who control AI control all the resources, and that's another future. And I don't. It depends on the day in which you ask me which one's likely.
You mentioned consciousness, and excuse me, I wanted to get your thoughts on consciousness, and also as somebody who's sort of struggling to understand it myself, and so is our audience. Can you give us your insights and maybe how we could better understand what exactly is consciousness?
Well, yeah, again, I wrote the last chapter of my new book is on consciousness, which is the hardest of all the scientific concepts to understand. It's not even well definable. Life is hard enough to define. Consciousness, most researchers on consciousness, I discovered, really steer away from defining it. It's like that judge said about pornography, and you know it when you see it. It's hard to define, but I think the idea of self-awareness and planning and intentionality, they're all part of it. But this notion, clearly the notion that there's a me inside me is an illusion in some sense. It arises out of the complex workings of the human brain.
Yeah.
But saying that it's an illusion doesn't add much of anything. Just like saying time is an illusion doesn't add much of anything if you're late for a train or something, but it has a real impact. And so the question is, how does that illusion arise? And there's a big problem because we don't know how unique we are in certain areas. We can't interrogate dogs. My dog, I have one of my two dogs here sleeping there, and they certainly seem conscious and aware of what's going on, sad, but one never knows if you're anthropomorphizing. And even ourselves, what is quite clear, and experiments have shown, and I describe several in my book, that we're not aware of our own consciousness. We're not aware of the processes that cause us to create this narrative that connects one moment to another and puts us at the center of it. There are many other processes going on behind the scenes, and we rationalize, as I said, reason is the slave of passion. We rationalize things that we may not realize are not happening, really. I mean, there's a great example, a split brain experiment, and with people who are epileptics, the corpus callosum that connects the two hemispheres of the brain is severed in some of these people. It reduces the frequency and intensity of epileptic seizures. But that means the two lobes of the brain don't communicate, and there's a great chance to do experiments. And we do that. I'm not going to go into the experiments, but you find out that people say things that they do things, and then they explain why they're doing things, and their explanation is wrong because the speech is the left hemisphere of the brain, and the right hemisphere has been doing the actions, and the left hemisphere is trying to come up with some story that makes sense for those actions. And so it's a really difficult area to understand. Erwin Schrödinger, who's a physicist, once said that consciousness is a singular of which there is no plural. And the idea is that we know of our consciousness, but we don't know any other. And that's why I think, by the way, that maybe AI will be a useful tool to help us understand our own consciousness. If we create a consciousness, we'll understand how it arises. I think there's a lot of factors, feelings, the necessity of being able to probe your internal state in the outside world. But even then, my friend Noam Chomsky, who I've talked to about this, has said that he thinks maybe this fixation on the nature of consciousness and the mechanisms of consciousness may be misplaced. We may one day just have a mathematical theory of how the brain works in a way that we have a mathematical theory of electromagnetism, and we don't worry about anything other than the mathematics. Maxwell, when he developed electromagnetism, and wheels and pulleys is a way of sort of some mechanical picture of these mathematical equations that he developed. Them. You don't think of those things anymore. And so anyway, the whole question may be misplaced, but it certainly is one of the deepest mysteries of being human is how we can sense our existence in the world and have intent. It is remarkable. And whether it's and how evolutionarily it arose, and whether it was whether consciousness itself was part of natural selection that allowed humans to reproduce and exist, or whether it was an accidental byproduct of other things that were necessary for humans to exist, is a fascinating question. I don't have the answers to any of those. Long answer without a lot of information, maybe.
Yes.
Well, you mentioned about AI being able to find these new answers to scientific problems that we don't know yet, and that's actually one of the.
Yeah, I mean, both being able to data mine and therefore look for correlations, but also quantum computers will allow us to do certain quantum mechanical calculations that we can't do otherwise. Sorry to interrupt, but go ahead.
No, that's actually exactly where I was going. Is the idea of quantum computers being able to simulate reality?
Yeah, I mean, we use computers to simulate reality, right? I mean, when we look at climate change, we're doing massive Monte Carlo models with lots of variables that allow us to basically run possible futures to see what the likelihood of certain climate changes are for certain inputs. And since there are uncertainties all around, you have to run many of them to get a locus of an ensemble of possible futures. But that's all classical. What the world is not classical at a fundamental level. It's quantum mechanical. And even simple quantum mechanical problems with 3 particles become intractable analytically for us to solve exactly. We can approximate them numerically. But a quantum computer could actually do the calculation by basically reproducing the quantum modeling the system in a way that we can never do, and avoiding the in a sense the almost infinite number of calculations that are required to get to an exact final answer, by basically reliving the situation in a quantum mechanical way. By taking 3 particles and simulating them in a quantum mechanical way, it can reproduce their quantum mechanical behavior in a way that we can only approximate. And so I think, and this again comes from conversations with lots of people working on quantum computing, where quantum computers will be most useful in the near term, certainly, is allowing us to do quantum mechanical calculations, molecules, maybe drug development, that kind of thing, or understanding chemistry. There's talk, about banks and code and error correction, and all that stuff is nice down the road, but I think that's probably not the first and most useful practical implication of quantum computers. It'll be an understanding the world, and that's what Richard Feynman said. Richard Feynman was one of the earliest people. The physicist Richard Feynman, I wrote a book about him, a great physicist. When he first discussed quantum computers, he basically said, well, it'll help us understand quantum mechanics. And this was from a guy who won the Nobel Prize for developing a quantum mechanical theory of electromagnetism. And I think he's right there. I think that's probably, it'll help us understand the quantum mechanical world in a way that we literally can't exactly, because we can never do the mathematics practically to be able to understand that world. And who knows if it'll allow us even more, if it'll allow us to understand frontier areas of physics like quantum gravity or the center of black holes. In certain very limited ways, people have tried to use these quantum computers to understand black holes in one dimension. I don't think it's not realistic, and I think it's hyped right now. But maybe in the future they'll help us understand mysteries, because we don't have a quantum theory of gravity, right. And maybe quantum computers will help us develop one. Who knows?
I want to get your thoughts on how do you believe sort of life got kickstarted? And second part of that is, are we alone? Do you think that this is an exclusive thing, or is there other organisms of some sort scattering the universe?
Well, I mean, those are great questions. I mean, and you know, I don't really hate to keep referring to my book, because I like referring to my new book, but you know, in each chapter, I basically introduce a major scientific frontier and list a series of questions. And in my chapter on life, the two questions you asked are two central questions: how did life originate, and are we alone? And they're not unrelated, obviously, because if we knew how life originated on Earth, we might have a sense for how easy or difficult it would be to originate in a cosmic context. By the same token, it worked the other way around, and I think this is more likely. We are getting close to understanding a chemical pathway that may take chemistry to biology, because even the earliest forms of life on Earth, we now think of an RNA world. RNA is, you know, we think preceded DNA because it could have had all of the genetic properties plus catalytic properties that allowed reproduction and the creation of proteins that are necessary for life to evolve. And the discovery that RNA was not only just a messenger, a genetic messenger, but also had certain properties of catalytic properties that enzymes have, won the Nobel Prize, and it's very important. So we think that before DNA was an RNA world, but RNA is still darn complicated. Sure. How do you get to such a world? And people have come up with potential mechanisms. And what we now realize is that exotic environments, like comets, perhaps, or certain places on Earth, where there are extreme environments, chemistry behaves a little bit differently than it does in the kind of normal environment, where we normally see complex molecules break down into simpler molecules. That you can do without energy. It requires energy in the body to build up complex carbohydrates and proteins. We need to eat donuts and get sunlight and all sorts of stuff in order to be able to have the energy to do what we do. But in certain exotic environments, it turns out the laws of chemistry and physics called entropy, basic enthalpy, not entropy, but enthalpy, free energy, can drive you to actually create more complex molecules. That's a real surprise. And then now the super cold environments, it turns out where normally reactions slow down, in certain cases, you can show reactions that would otherwise be improbable can speed up. All these are new developments in the last 10 years that may help us understand those earliest moments where you formed the first self-replicating molecule in a membrane that had metabolism. Because again, life requires a lot of independent features. And if I ask you to define life, and I won't now, but rhetorically, if I ask you to define life, you'd probably come up with an answer which wouldn't be complete. And the example I like to give is fire. Fire has most of the characteristics I bet you would come up with for life: metabolism, reproduction, all sorts of things. But it's not life. Living systems have homeostasis, where they can have controlled reactions, which life can't. And having controlled reactions is important, because otherwise you run away and oxidize. Life is just controlled burning, and if it's uncontrolled, you burn. And if you have the uncontrolled burning, you don't have any energy left for the system afterwards. We're very lucky there wasn't any free oxygen on our Earth early on, because all of the organic materials would become oxidized and all of their available energy would be gone. Anyway, so I think it's quite possible in the next decade or two we may unravel the chemistry, a possible route of chemistry. It may not be that we may not be able to prove is the way it happened, but at least to see how it could possibly happen, which is nice, especially when you're confronting people who say, "Oh, you need God." But I think equally important will be the search for life elsewhere in the universe, because, like AI, life is a singular in some sense, of the plural of which is unknown. We know of life on Earth. It would be very instructive to discover the existence of independent life forms elsewhere in the universe. it would teach us a lot about the evolution of life. It would teach us about how unique do all living systems everywhere in the universe use ATP and the same 4 base pairs of DNA, or are there other routes to having living systems? And so I think it's just as likely that our discovery of life elsewhere in the universe may reveal to us our own origins, as it will be that AI will reveal to us in some sense how consciousness works. And there I'm quite optimistic, not so much for AI, but for life, because we have a lot of new tools that are allowing us to look at potentially discover life elsewhere in the universe, in our solar system, perhaps in the oceans of Europa, Enceladus, and deep under we see organic materials, we see geysers. They're separated from space by layers of ice, kilometer thick layers of ice. And so if we discovered life in the oceans of Europa or Enceladus, it would probably we'd have high confidence that it's an independent genesis of life. Now, this is like microbial life. I'm not expecting to find, intelligent beings in submarines. But we're also looking at distant planets now. We discovered planets around other stars, and thousands of them. And we can actually look for some of them, if we're lucky enough, and they get in front of the star, we can see the light go through the atmosphere. And then we can look at the spectroscopy of the atmosphere and see what elements exist in the atmosphere and see if they're byproducts of life. And so I suspect within the next couple of decades, I'm optimistic we'll discover evidence for life elsewhere in the universe. I think it's likely. Now, that's not intelligent life.
Right. It's life.
And there's a big difference. And I'll be debating in New York in beginning December, a person who somehow may think that some of the things that are seen that are unidentified are UFOs, are aliens, which they aren't. But I have to disabuse him of that notion. But whether intelligence exists is a much more complicated question, since we don't know even what led to intelligence existing on Earth, and it took 4 billion years to do on Earth, and we don't know if that's common or rare, and that's where I think it's much less likely we'll get extra information, because we'd have to be very lucky, even if intelligent life exists elsewhere in the galaxy, to know about it. It's a big galaxy, right. And how we know about it is if you think about it, the odds are so daunting against it. It doesn't mean we shouldn't look,
right?
But it's highly unlikely, which is one of the reasons, by the way, aliens aren't coming here, because they don't know about it.
Oh, man, I feel like I really hope that we get a chance to talk to you again. There is that last commentary you gave. There's so many things in that right there.
Time packed, yeah.
Oh man, I really hope we get another chance. So let me just
let's do it.
Call myself
early today.
No, it's okay. We're just glad. I'm really excited about having you here. Me and Louis talked about this, so this is a big deal. But I want to know. I've been learning about systems theory for the last, I don't want to say 6 months. I don't understand it fully at all, to be totally honest.
What have you been learning about?
Systems theory. So the way that I understand it is that everything pretty much and this is a societal, I look at it through the lens of society. Mm-hmm. There's something wrong with the way that civilization, like we're all, chaotic and not unified and disorganized, and we're kind of rushing towards our own oblivion. Yeah. And I feel like there are other systems that we can implement aside from, and I'm not saying to get rid of democracy or any other idealistic, systems, but there has to be a system that could be better for us. And I looked into people like Jacques Fresco, the resource-based economy, the Venus Project, all this stuff like that. What kind of system might be better that in conjunction with democracy, or if we were to go beyond that?
If I knew, I'd be doing it, wouldn't I? I mean, that's the problem. I think, there's that old statement, democracy is the worst form of government except for all the others. We're stumbling along. And the reason I do physics is because it's easy. Trying to understand how society works is a very complicated, really complicated problem. And it's often only understood by the empirical failures, and try to stumble forward. But it would be great if the one thing that we could implement, if we could just implement one thing, I'd have a lot more optimism, and that is rationality, and the scientific method, empirical testing of ideas. Do policies. If they don't work, change them. Don't be afraid to say they didn't work. Base your policies on empirical evidence instead of what your base would like. all of these things, and then having a public literate enough in key areas of how the world works to be able to vote for or otherwise impact on their leaders, so that there would be consequences for bad actions, and the public would be able to determine good actions from bad actions and good actors from bad actors. And so I think that's why I do what I do, in some sense, that an informed electorate is an essential part of a functioning democracy, and we are far from that. And education is a key part, and that means that, and in the modern world, that means educating people to distinguish information from misinformation. And I think that we have to revise the way we sort of educate people in a world governed by the internet, to be able to ask questions and be able to discern to be able to distinguish misinformation from information by looking at many sources and testing ideas. And so I think what we really need to do, in my opinion, regardless of the form of government we choose to govern ourselves, is we need to use the scientific method to help be the basis of policy, the policies that government enacts, and the way that policies change, and the way the public has control over those policy changes. So, there's an interesting question whether you can ever have a democracy without science, or whether you can have good science without democracy. Interesting question, because China right now doesn't have democracy, but it's certainly, at least in the laboratories, it's allowing researchers to ask any question they want, and not controlling that aspect of their progress. That's an essential part of science and human progress, is to not have anything be sacred, and not to have any questions that you can't ask. Now, that's what worries me about our modern society in the West, is we're increasingly getting to the point where in universities and other places, people are not allowed to ask questions if some people think the answers might offend them. And that's a real problem. And
I agree with
of late.
100% agree.
My last deep question before we give you a chance to chat about your books and your podcast is about the universe. Are you more of a believer in a singular universe, or sort of the multiverse theory of repetitions, copies, that type of thing?
Well, I mean, again, these are deep questions and hard to answer quickly, but
sure,
I think that the laws of physics, as we now understand them at a fundamental level, are highly suggestive that we live in a multiverse, that our universe is one of many possible universes, and the laws of physics may be different in many of them, and that changes everything if it's true, because it means that the laws of physics that we have may be accidents, that's very different than when I grew up, when I tried to understand why the laws of physics have to be what they are. And there are reasons for why we think the multiverse is likely. Well, basically, at a fundamental scale, when we think about how our universe evolves, in the early history of our universe, it's quite likely a process happened that basically involved uncontrolled growth of space. And in local places, that uncontrolled growth ended and produced a hot Big Bang, like our Big Bang. But the rest of space is still expanding. In other places, it may have ended and may yet end. And so there could be universes being spawned, having been spawned before our universe and after our universe. And it turns out, depending upon how those universes are spawned, the laws of physics could be different, or at least the effective laws of physics that they measure could be different. And that's quite interesting, because then you could ask why, can life only exist in certain of these universes? These are fascinating questions, but right now they're mostly metaphysics, but we can turn them into physics with experiment, which is why I think it's worth talking about them. So anyway, I'm betting we live in a multiverse. I wish we didn't, by the way. I'd like just one universe, but
too many calculations.
Because then maybe I could try and understand why the universe had to be the way it is. There might be some fundamental arguments that suggest that, which is certainly what drove me to be a physicist. But the universe doesn't care what I like or don't like, and neither does the multiverse. And so I have to just live with one or the other.
Yeah. before I really don't want to miss this. I gotta say, first of all, thank you for being here. This is awesome.
No worries.
Big deal for me personally, because again, I've watched your talks for years. It's weird. It's weird having you here, realizing you're a human
Hopefully
being.
not too weird. That's good.
It's awesome weird. Like I can't. It's surreal. It's surreal.
Thanks.
And I do want to say I do look forward to having a longer session at a later time. I'm just glad you're here at all. And if you
I
can,
enjoyed this, and I'm happy to do it. It's just it's a busy time at the moment. But hopefully, in terms of your listeners, will whet their appetites rather than distract them, and maybe it'll be good for a later talk.
It was a success. And if you can, when you get a chance to talk to Robert, please tell him if you can connect us, it would be really awesome. I would love to talk to him and pick his brain, especially about like society and the human condition and so forth.
Just to give you a sense, it took about 4 years of coordination before Robert and I finally were able to do an event to do it.
You never know, the universe.
So now the hard work is done. It should be
I just passed him off.
Yeah, exactly.
Yeah, sure. Well, I'm sure I expect he's getting a lot of demands right now because of the big book, and he likes to hibernate. But yeah. Anyway, well, but one thing you can do with one of my Origins Project Foundation, besides running the podcast, we have public events, and I may do a public event with him. That you can come to, but we also run trips where you can spend a week with people, and I think Robert's going to do one of our Origins Project trips with us, and then so you just have to come, maybe Bhutan or the next place we're going to go do a trip, and then you can spend a week with him.
Perfect excuse for a vacation. Lawrence, tell us where people can find out more about you, your books, your show.
Wow. Okay. Well, hopefully you can find my books anywhere you find books, Amazon or anywhere else. You can I have a personal website, lawrencemkraus.com, which we try and keep up to date about books and events and writings and stuff. It's been redone, so it's not fully up to date yet. But also the Origins Project, of course, where you can see the podcasts and also get linked to our Substack site where a lot of my writing is done now. Is originsproject.org, and I tend to tweet at lkraus1 when I have something either upsetting me or interesting to say, and those are some places. I'm not hard to find. You just it's easy.
You're a big deal.
Seem to be able to. So
you're a big deal. Don't be humble. You're a big deal.
Anyway. Okay.
Well, thank you for joining us, Lawrence. We'll be respectful of your time. I know you're in a hurry. Again, from the bottom of both of our hearts, you made a couple Science Guys Day, and our audience will love you as well. You are welcome back here anytime when you have some more time. I know these are deep, complex things that you could discuss at length. It's hard to squeeze it into a few-minute answers. So
this has been fun. I really enjoy it. Wherever you guys are, I don't know where you guys are. Where are you located?
I'm in Canada on the West Coast. Marquise is in Pennsylvania.
Yep.
Pennsylvania. Okay.
So we got both sides of the border covered. And you grew up in the same hometown I did. You went to school in Ottawa. I worked in Ottawa for 3 or 4 years. So
and then I just did a public event in Vancouver. So if you're in the West, are you in Vancouver?
Yeah, about half hour east.
And you didn't come to it?
I didn't know you were there.
Okay.
Let me know next time, please. I will be there. I'll bring you coffee, whatever you want.
So Pennsylvania, if you get near New York, I'll be there December 1st. Okay.
December 1st, I'll see you.
Sides. So thanks again, Lawrence. We do really appreciate it again. And lawrencemkraus.com, everybody, if you want to check out his work. And with that, we'll bring today's show to a close. So I want to say thank you to our guest, Lawrence Kraus. And on behalf of Marquise Williams and myself, Louis Borges, wish you all good health. Take care of each other. And we'll see you next time.